Let's look at another example. I'd like to solve another triangle. This time I know side A is 75.0 inches, B is 63 inches, and angle A is 54 degrees. So I'm going to start off again by sketching a model triangle. And when I go to sketch that model triangle, the information again that I need to solve for is going to be in red. You'll notice again I have a matched set. I have A and angle A, side A and angle A. So if I set up my ratios using the law of sines, I'd have sine of 54 degrees over 75 is sine of B over 63 is sine of C over side C. So my choice here to solve for something first is going to be fairly obvious because I don't know either thing about C. But if I found angle B, I'd be able to find the angle C. So I'm going to start with sine of 54 degrees over 75 is sine of B over 63. Cross multiply gives me 75 sine B equals 63 sine 54. When I solve then for sine B, that gives me 63 sine 54 divided by 75. And I learned that sine of B is approximately 0.679574,275. And like we did in previous examples, I need to get the angle, so I do the inverse sine. And so the inverse sine of that number gives me approximately 42.8 degrees. Now, as I said before, now I know two of the angles. I can use the 180 degree angle rule, and I get that the third angle, angle C, is 83.2 degrees. Now, I can use that to find side C, which is the last thing that I'm missing. So, sine of 54 degrees divided by 75 is equal to sine of 83.2 divided by C. When I cross multiply, I'm going to end up getting that C is 92.05 inches. So, a couple of comments, and then we're going to move on and take a look at another little bit of examples and an issue that comes up. So if you're given three parts of a triangle, and it has to always include one side or more, you can solve the triangle by finding the other three parts, or by discovering there's no triangle that supports the given configuration, in which case there's no solution. Two triangles are considered to be the same if they have the same values of A, B, C, and little a, little b, little c. If you're only given the three angles, angle, 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 then you have an entire family of similar triangles. So we're not going to be looking at an angle, angle, angle situation. On the other hand, it's possible that no triangle can support a given configuration. And then we're going to talk a little bit about the ambiguous, the side-side angle case, where we might actually end up getting two different triangles. And again, the law of sines is applied in cases where you know two angles and one side, and what you always need to know is you need to know the side and an angle opposite that side.